just a reminder for me more than for you of what's coming up. I think we had settled on the 21st for the test. Is that right? Test 2, 21st? I didn't write it down, which is, so I thought I should do it now. I think we said the 21st because the 26th is the day before Thanksgiving. Well, not the day before, it's 2 days before, but everyone's going to be packing up. So I think we had this for test 2, if my memory serves me correct. And then we will have some sort of, I didn't put it, weighted voting homework 2. So we have homework 1 due today. It's listed online. I haven't put weighted voting homework 2, but I'll tell you what it is. It's pretty simple. So let's deal with the weighted voting homework 1. And in particular, we can go back and do BANSAF, but what I really am interested in is this issue with the United Nations Security Council, just because it's interesting that you have a situation that is described sort of in a way that seems logical, but it doesn't have the weights, and it'd be nice to be able to analyze it mathematically. So I'm not sure how you approached that, but let me just show you how I approached it. And you might have taken a similar tack. So you know that there's going to be 15 members to the United States, or UN, the United Nations Security Council, and that the 10 non-permanent countries, they all don't have veto power. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we have, I'll just put little spaces here for the 5 permanent members. They all have veto power, and presumably they have the same amount of power. So what I would like to do is I'd like to put some number in there to capture this idea that they have veto power, the other ones don't. We need a total of 9 votes to win. And so, I forgot my quota. Let me get rid of this and make room for the quota. So here I'll put a little room here for the quota, and then we'll put numbers here. So one way to approach this is to use some algebra and to try to work through exactly how much of each of these votes we need. But another way is just to guess. I mean, that's one way that math is done, honestly, is sometimes you just try something and see if it works. And so you think, well, if so I'm not going to, I don't want to poo-poo anyone's work. If you did algebra and you got the number that works, you're amazing. I've done that before, but let's just guess this time. So anyway, just guessing, you might say, well, since you have veto power, you would think that if these all have 1 vote each, maybe if we give the people with veto power 10 votes, that way they can dominate. Let's do that and see what happens. So 10, 10, 10. You could give them each 100 votes. I mean, honestly, it really doesn't matter. As long as you give them at least, actually, I don't remember the exact number. I think it's 6 or 7 votes is the minimum that they need to have. But you pick a number. Actually, any number will work. I'm just picking 10 because I'm pretty sure that that's going to work. And it feels good. It's a nice round number. Now let's talk about the quota. So each of these people must have veto power. So I need the quota to be big enough so that the motion cannot pass without all 5 of these people voting. In other words, the quota has to be at least 50. Because if the quota is less than 50, say the quota is 48, then you can have 4 of those and 8 of these, and everything would pass. So we got to have at least 50. But we want to make sure that it only passes when you have 4 of those people, 5 of those people and 4 of these people, because the rules are we need 9 votes. So in terms of the way that the Security Council works, they just raise their hands and say yes, no, or whatever. Maybe they just say it into a microphone. But so technically you need all 5 of those and a minimum of 4 of these. Well, let's count it up. 5, 50, plus 4, 54. And then you can double check to see if this works, but it does. So if you look that over, everyone over there, those 5 people have veto power. These 10 people over here don't have veto power, but in order for something to pass, you need all 5 of these plus 4 or more of these people. So I'm sure that you probably came up with a different number. Did anyone figure out the minimum? If you did it the algebra way, you probably found the minimum. So Did anyone do that? Or did anyone do it? Maybe you did a guess and check as well. I don't know. But do you have different numbers? Because there are different ways to do this. I'm just curious. I'd like at least one other set of numbers. If you have one that you want to volunteer, you have a different set?
I use 7.
You use 7. 7 works. So let's see. If you used 7, 7, 7, 7, and 1 for the other numbers? Yeah. So you honestly, you could have used 2 for these. 7, 8, 9, 10. You could have used 2 or 3, but then that would change the calculation over here. So 1 is an easy number to use, and then 7, if that works. So I'm guessing that if you add up those 7s, you get 35, 36, 37, 38, 39. So we need 39 votes to win. Is that what you have? Yeah. So there are, like I said, there's other combinations of numbers that work. This is just a springboard to try to figure out how much power each of these people has in relation to one another. So there's nothing magical about the 7 or the 10, as hopefully you've figured out. The number of votes you have is not how much power you have. So if we made those all hundreds and these all ones and just adjusted that, I think that would have to be 504. It would still be the same power balance. So the numbers are just there to, votes, number of votes really isn't power. So before we look at the other homework, as long as we've got these, I'll use mine, but you could use yours. It really doesn't matter. Mine only because it's got nice round numbers. I like those 10s. Let's see, can I delete? Yes, I can. Sorry, not that yours, like I said, yours is beautiful. I love it. I just want to see how much more power do the people with veto power have than the non-permanent members. Now, right off the bat, though, permanent members are permanent. So they already have a ton of power compared with the non-permanent, like Uganda or Bolivia or whoever it is, Haiti. They all get to be on the Security Council once every 15 years or whatever. I don't know what the cycle is, but it's not very frequently. So the US, China, Russia, whoever else, France, they all have way, way more power just because they're always on there. And then, but once you've set, like for this year, how much more power do these people have? So let's actually do it. This isn't too bad. I'm going to name these people. The permanent members are going to be A, and the non-permanent members are B. Okay, whatever. You get the picture, dot, dot, dot. So winning coalitions. I could list off all of the coalitions. How many will there be? There's going to be 2 to the 15th. That's way too many. I don't want to list them off because there's 15 people. 2 to the 15th are the number of coalitions, well, minus 1 if you get rid of the empty one. Most of those are going to be losing coalitions, though, so let's only worry about the winning coalitions because those are the only ones that matter for the bands have power index. So winning coalitions are going to look like this. All of the A's have to vote yes, and any number of B's where you have 4 B's or 5 B's, here we'll do this, A to the 5th, B to the 5th maybe, just to simplify, A to the 6th, B to the, or sorry, 6th, there is not 6, 5, B to the 6th, and then 7, 8, 9, and 10. Maybe I should do it, you know what, I will do it this way. How about this? The number of B's, and then number of coalitions. Because that's what really matters. So if you have 4 B's, so that's this one, how many coalitions does that represent? Well, you're going to get all of those. So you need to choose out of those 10, you need to choose 4 of the B's. So 10 choose 4. There are 10 choose 4 coalitions that look like this. 10 choose 4. And then for 5, you can probably guess. If there are 5 B's, then there are 10 choose 5 coalitions that look like that. 10, oops, I'm getting ahead of myself. For 6 B's, there are 10 choose 6 coalitions that look like that. For 7 B's, there are 10 choose 7. For 8, there are 10 choose 8. 9 will be 10 choose 9. And then, of course, there's only one coalition that has all 10. Now, here's the interesting thing. For the A, if you're a veto power person, you are critical in every one of these winning coalitions. But what about the B? Which of those is the B going to be critical? Is B ever critical? Which one? Yeah, the 4. That's the only one, right? Because if there are 5 B's that say yes, then any one of those could just say, I don't, they change their mind. And it just goes back to 4. It doesn't change it's winning or losing. But even if you have all 10 saying yes, if just one, if China says no, then suddenly it doesn't pass. So here's how we're going to do this to figure out how much power the A's have. The A's are critical in every one of these. The B's are only critical in this one, but not all of the B's are there. So we're gonna have to do a little bit more work here to figure out how many ways a B is critical. But don't worry, it's not gonna be too much more work. So basically, to figure out how much power the A's have, each one of them is critical in the sum of those. So those numbers aren't terrible. So I know, let's see, I'll start with the 10. 10 choose 10 is 1. 10 choose 9 is 10. 10 choose 8 is 55. No, 45, sorry. How did I get that wrong? I used to have these memorized. I mean, because I'm a combinatorialist, and so I should, but let me just do it out. Binomial 10 choose 7 is 120, of course. And then is it 252? Let me check. Oh, it's 210. Interesting. So 210, and then it's the 5. I knew that was there somewhere. Okay, so then it's 210, and then 252, and then it repeats itself. So 210. So that's the 4 is on the left. That would be the top one. 10 choose 4. So 4, 5, 6, 7, 8, 9, 10. And we can add those up. So let me do that. Binomial in goes from 0 to 666. Let's see if that does it. 848. Hopefully I got it right. So add all those up. 848. So in 848 of the coalitions, each of the A's, each one of them is going to be critical in 848 of them. Okay, let's look at the B's now. So the B's are only critical when they're here, but that only has 4 of the B's, 4 out of the 10 B's. So let's think of let's put a particular B in here. Let's call this B B1. Maybe that's Burundi, B Burundi. But whatever it is, it's one of the B's. So we'll put a little box around it, that B. Well, that B will be critical as long as it and only 3 of the other B's are voting yes. So how many ways could that happen? Well, we're sticking the Burundi or whatever that B is. And then the number of ways of having 3 out of 9 is 9 choose 3. And so, once again, I used to have these memorized, and 84 is the number I'm getting. So 84 for that. So each of the B's will be critical only 84 times. Interesting. I chose my numbers almost perfectly, didn't I, in terms of 10 and 1. So each of the permanent members has about 10 times the power of the non-permanent members. You would have gotten exactly the same result if you did the bands have power index with 7s and 1s, or as long as this is correctly chosen, or if you chose any other number here. 7 I think is the lowest. Let's see, if you did 6, 6 times 5 is 30 plus 4, 34. Yeah, you could replace one of the non-permanent or the permanent members with the 6 so the 6 doesn't work, but 7 does. So 7 is the minimum. Nice work. Okay, so anyway, I just found this to be interesting, that this is true of any time you have some sort of a situation where there's the voting is dictated by some weird system, you can always come up with what it would be in terms of the numbers, and then figure out how much power, what the power differential is. So 10 times the power apparently. But then if you factor in the fact that these people are non-permanent, there's probably even 100 times the power for the permanent members. Okay, onward. What about the other problems? Did you have any trouble computing I think it was just up to 4, right? There were only 4. So 4, it's not too bad. There's only 16 or 15 coalitions you have to worry about. But did you have any trouble with any of those? And I tried to pick ones where it was kind of, they were all different, weren't they? It's like different results, because it gets a little boring when they're all the same. When you have small numbers, sometimes it gets boring when you do a bunch of them. So I only just 3. Okay, if you're happy with that, then why don't we move on? Where's my PowerPoint here? Here we go. PowerPoint land. Okay, so Banzhaf Power Index. This guy, he was looking at this back in the 1950s, same time as another group of researchers, Shapley and Shubik. So in the 50s, they were thinking of the same thing. You know, this typically happens is you'll have some sort of a research interest among mathematicians. A couple of different people, maybe more than a couple, start working on it. This happened back in the 1600s when Leibniz and Newton were both working on the calculus, and they both came up with rival versions. They were basically the same, just slightly different notation and stuff, but basically developed it at the same time. So Shapley and Shubik came up with their own version of this, but they were focused on a slightly different thing. So philosophically, this is different than Banzhaf, but interestingly, despite the fact that this is different, it ends up coming up with similar results, not quite the same as Banzhaf. So just to warn you, this isn't quite the same. So you might think, well, why would we do this if you get the same result? It's not quite the same. So what Shapley and Shubik did was they said, let's suppose that people are voting. It's the person who casts the deciding vote. The deciding vote, that's the person who is the most important. So if you can imagine the Congress, I don't know if you've ever seen part of a roll call vote. At Congress, they'll read off the names of the people, the Congress people, and they'll say, you know, Mr. Smith from Arkansas, and he'll say, yes, or whatever, I don't know what they say. And then they'll do Mr. whatever, or Miss, yeah, they'll go through the list of all 435 Congress people, and they'll ask, how do you vote? And they'll say yes or no. I think this typically happens in the Senate more than the House, because the House requires a lot more time, but it does happen sometimes in the House. So when the threshold goes from below a majority to a majority, that person who casts that vote is special. I mean, aren't they? They're kind of special. It's like, well, it wasn't passing and now it is passing. I feel special because I cast the deciding vote. Now, of course, there's other people who voted beyond that person that might have said yes, but that person who casted the deciding vote, that person is special. And so that's the person that Shapley and Shubik decided to focus on. And so what Shapley and Shubik said is, let's say that we line everybody up and we have them vote. And let's just assume everyone's voting yes, just for the sake of making it simple. If there are some no voters, it's okay, because you can push those voters to the end, have all the yeses come and then the no's, because we just want to know the deciding vote. So who casts the deciding vote? That's the question. So a permutation, you know what this is, but this I had to for people who don't know. And then the pivotal voter, this is the person that Shapley and Shubik were interested in. They're like, it's the first voter, the first one who, when they joined the ones before them, they pushed the number of votes above the quota. So that person, that one is pivotal. So we use slightly different language, and that's the one that they're fixated on. They're the one they're focused on. So since we're dealing with permutations, if we go back to our discussion of where is Wapney? Here we go. Oh, I've written on this. It's all right. Yeah, I've written on all of these. That's okay. That's okay. So back here, so instead of thinking in terms of like the actual votes, yes and no, we're going to just line them up. So we could do something like this. So here I'll change colors just so that we can see. You have Watney, Martinez, Lewis. That's one way of voting. Watney, Lewis, Martinez. So you see, this is the permutation. We'll have Watney vote first, then Martinez, then Lewis. And let's just presume that they're all going to vote yes for the aforementioned reason, that if someone votes no, we can just ignore them, push them to the end, whatever. So then we have Lewis, Martinez, Watney. Let me write that. Do we know how many I'm going to have to write down? I think I messed up there just a sec. So I was thinking and talking and writing at the same time. How many of these do I need to do? There's 3 voters. So how will I know? Like over here, we figured out it was always 2 to the n minus 1 was the number of combinations or voting groups, blocks. What about this? How many permutations will there be of these 3 people? You can do it. Probability people. Make me proud. You know it? What is it? 6. It is 6, yeah. It's 3 factorial. Come on, bring it on. I know it's early. Yeah, it's 3 factorial. You have 3 choices for the first person, 2 choices for the second person, 1 choice for the third person. Oh, this is recording, isn't it? You realized. Oh, yeah. I did it. Good. Okay, so you have Lewis, Watney. Oh, come on, Watney, get on there. And then Martinez. Okay, so there's going to be 6. What are the other 2? Martinez, Lewis, Watney, Martinez, Watney, Lewis. So there are our permutations. Now, to remind you, we like all of this stuff in red we had done without the notation. So that was just sort of the prelude. So let's write down the notation. I believe that we had 3 votes to win, or at least that's what we decided on. And then you have Lewis, Martinez, and Watney. So you have L, Martinez, and there, LMW. So who casts the pivotal vote in each of these? That's the question. So let's go through and decide. And so it takes a little bit of sort of mental, space, or you could use a calculator to keep track. But I think we can do this one in our heads. You have Watney, 1 vote so far. When we get Martinez to vote yes, now we have another 2. That makes 3, and Martinez is the person who cast the deciding vote. Maybe you can think of it this way. We go and we try to convince these people in this order to vote yes. So we get Watney to say yes. That's only 1 vote. It doesn't change anything. We get to Lewis. That's another 2. Total of 3. Lewis is the pivotal voter. So I think you could probably quickly get through this. Lewis has 2 votes. Martinez has 1. That brings us up to 3. Lewis has 2 votes. I'm sorry, Martinez had 2, didn't they? But anyway, Lewis, Watney, same thing though. Martinez 2, Lewis 2, that brings us up to 4. We're good. Martinez 2, Watney is 1. There we go. So in this case, you will always have n factorial, which in this case is 6 different permutations. And so now you're just going to count how many times is Martinez pivotal, how many times is Lewis pivotal, and how many times is Watney pivotal. And it turns out that they're all pivotal the same number, so they all have an equal sway, but that's what we had discovered earlier. But let's write it down. Martinez is 2 out of 6. Watney is 2 out of 6. Sorry, I got distracted by his number of votes. But it's 2 out of 6 because he's, see, look, right there, 2 out of 6. And then Lewis is also 2 out of 6. They all have the same amount of power. Let's see if you can do something like this with a slightly more, not too much more, don't worry, slightly more complicated situation. Oh no, we'll do the easier one first, then we'll do the harder one. So let's do this one. This one's pretty easy. So go ahead and you can name these people. I don't care what you call them, if you want to call them A, B, C, or if you want to stick with the P1, P2, P3, whatever's going to be easiest for you is fine with me. So list off, there's only 6 permutations, figure out who's pivotal in each case, and then just add up the number of times each person is pivotal. Okay. Well, let's see how we're doing. Jaron, you get to decide. Are we using ABC or P1, P2, P3? All right, excellent. We'll do ABC. So since you're picking, tell me the permutations that you wrote down for ABC. All right, we got all 6 of them. So 6 factorial, or 3 factorial is 6. Very nice. So now we just have to figure out who is pivotal. So who casts the deciding vote in each of these? So let's go ahead and just go through the list here. Zane, you're up first. What about that top one? Who cast a deciding vote there? B does, because you have 5 votes when you're at the A. Then when you get to B, it brings it up to 8, which is more than 6. Very nice. All right, Chelsea, what about the second one? Who cast the deciding vote there? C does. Very nice. So 5 plus 1 is 6. You're all set. All right, BCA. Let's see. Roston, what about BCA? Who gets the deciding vote there? A does? Wait, not C? Oh, yeah, B and C together aren't enough. Okay, yeah, B and C together are only 4. Then you get A, and you get more than 6. Very nice. Sarah, what about BAC? A again, yes. So A. Wow, I think I know who has all the power here, but let's just finish it up. Evan, what about the next one, CAB? That's also A. And then the final one, let's see, who hasn't gotten a chance? Reagan, what about CBA? A again, yes. All right, so now we can just list it off, can't we? This one wasn't too bad. Whoops, I don't like that color. Let's try this. So A is pivotal in 4 out of 6. So 2/3 of the power, 4 out of 6. And then B and C are both pivotal just once in 1 out of 6. So you can see how this will be similar but not identical to Banzhaf. By the way, the relationships here, a couple of things just to note, is that if in Banzhaf, if someone is a dictator, for example, they will be a dictator here. If someone is a dummy, that is, if they have no power, they will have no power here. If 2 people have the same amount of power in Banzhaf power index, it'll be the same in Shapley-Shubik. So in those ways, these 2 methods of trying to evaluate amount of power are they'll agree. But the one way that they don't agree is in the ratio of power. So in Shapley-Shubik, it says A has 4 times as much power as B or C. Let's actually just quickly do the Banzhaf power index. I'll just make a little box here just to do this. I think we might have done it for this one last time, but let's just do it again just to make sure. So Banzhaf. So I'm just going to help by writing down very quickly all of the winning coalitions. So obviously ABC is a winning coalition, A and B together, A and C together. I think that's it. Oh, yeah, it is. Okay, so who is critical? So in the first one, A is critical, but B and C are not critical. In the second one, both A and B are critical. In the third one, A and C are critical. So notice that this has a slightly different power dynamic or ratio. A has 3/5 of the power, 60%. B and C both have 20%, 1/5 and 1/5. So Shapley-Shubik, at least in this situation, says, hey, Mr. or Ms. A has more power than Banzhaf says that they do. So in Banzhaf land, it's 3 times as much power. In Shapley-Shubik, it's 4 times. Suffice it to say, person A has a lot of power compared to persons B and C. It's just this maybe slightly nitpicky thing of figuring out exactly what the ratios are, but either one of these makes sense from a sort of mathematical standpoint. Let's try this with another one of these, and then we'll talk about homework. So let's go over to, come on, there. It switches when I want it, don't want it to, and sometimes doesn't when I do. Okay, so this one, 753111. Before we get started, let's talk about how many permutations there are going to be for this thing. So yeah, I guess I can just pick someone. Yeah, you all know this. Zane, how many permutations am I going to have to write down for this?
I was going to say 5 factorial, but I don't feel like it's right.
It is right. Why don't you think it's right? It's a big number, isn't it? Yeah. And why would I have you do such a thing? I wouldn't do that to you, would I? No, I'm not going to make you write down 120. As you can guess, just like with the Banzhaf power index, or what kind of we did last time and today with the UN Security Council, you can shorten the number of things that you have to write if you combine. Like here, all 3 of those, the low numbers there, they're kind of all the same. You know, they're going to have the same amount of power because they have the same number of votes. And so whenever that happens, we can kind of shorten the situation. And let's just erase the D and the E. I guess I'm erasing all 3 of those. Let's just call them C. They're all C's. They're all indistinguishable. They look the same. They're triplets. You know, can't tell the one from the other. Okay, so if you have that, now this is going to require a little bit more maybe thinking. But some of you from probability, most of you, should be able to tell me how many distinguishable permutations there are. Now that I've combined those, said they're all the same, what do I do to the 5 factorial? Do you remember what it is? Yeah, you divide by 3 factorial, right? So let's divide by 3 factorial, divide by 6. And now there's only 20 distinguishable permutations. Once again, I'm just assuming that they're all the same. And so when I get done, because they're all the same, I will take whatever power they have and divide it by 3, because there's 3 of them. You'll see what I mean here in just a second. So let us write this down. I'm going to have to erase. Oh, see, it changes when I don't want it to. Okay, I'll erase that because I need room, because there are 20. That is not us, not nothing. So let's go ahead and see if we can list them off. I'll get you started. A, B, C, C, C is the first one. And then maybe I'll just move that B over. A, C, C, B, C, A, C, 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 B. So far, so good. I've got 4 of them. Well, 16 to go. All right, well, let's move the B to the front and do the same thing with the A. How about? So B, C, A, C, C, B, C, C, A, C, B, C, 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 A. All right, we're doing good. So if you have some sort of systematic way to do this, I don't know if you can tell what I'm doing, but I'm just trying to systematically list off all 20 and make sure that I don't duplicate anything. I mean, one of the things I've seen, like especially from like freshmen who are doing some course that requires them to write down permutations, is they'll duplicate a permutation like in a sample space for rolling or flipping coins, or they'll leave one off. So if you're systematic, you're much less likely to mess up like that. Okay, my next move is let's see, I think I've got all of the permutations where A is at the front and where B is at the front. Maybe you can tell me if I've missed any. So I guess I'm going to have to put C at the front now. So let's just put one of the C's at the front and do this. And then maybe we could put the B there. C, B, C, A, C, C, B, C, C, A. All right, I feel pretty good about this so far. How many do I have? I've got 8 plus 1, 2, 3, 4, 5, 6. I'm up to 14. Still just 6 to go, I guess. All right, so it looks like I've got all of the permutations where A is at the front, all the permutations where B is starting out, and then I've got all the permutations where C is starting and the next letter is not C. So let's do the ones where you have C to start and the next letter is C. So you have C, C, A, B, C. This isn't going to be hard, is it? A, C, B, C, C, B, A, C, 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 B, C, A. Almost done. C, A, B, C, 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 B, A. We got them all now. Well, let's divide up the labor because this is going to take forever. Well, it's not going to take forever, but there are 20 of these. And so perhaps maybe Sarah and Audrey could do the first 4, and then Reagan and Jaren could do the next 4. And then let's see, maybe, there's not going to be an even, wait, there's 5 of you. That's all right. So Evan and Sydney could do the next 4. So this is Evan and Sydney's batch right here. And then the rest of you guys, so Chelsea, Roston, and Zane could do these 4. So this is Chelsea, Roston, Zane, Evan, and Sydney. This was Sarah and Audrey. And this was Reagan and Jaren. And then I'll do the 4 that I didn't, so that way we'll get them all done. And so the job that you have is figure out who is pivotal. So which of these people, and sometimes it'll just be a C. So, move across and add up the numbers. I'm just going to highlight them like this, but my batch was easy. So I just realized that, yeah, this one is even easier because once you realize that A has veto power. Oh wait, does A have veto power? Yeah, A has veto power, don't they? So, yeah, it makes it a little bit easier perhaps. All right, let's see how we did. Sarah, Audrey, either one or both of you, maybe you could divide these up. First one, we'll divide it up. So Sarah, what about that first one, A, B, C, C, C? The B, okay, very nice. All right, Audrey, Sarah, the next one. The B also? All right, Audrey, what about this third? It's the C, this one? And this one's the C here, yeah, very good. All right, let's see, Reagan. Reagan, what about the next B, A, C, C, C? The A, okay, very good. All right, Jaren, what about the next one? Oh, I meant to do it the other way around. That's right. Reagan, what about the third one down? Why do they do this to me? And then the last one, Jaren? A. I need to give this person the stink eye. What is this? Let's wonder why. Is it a leaf blower? I hate leaf blowers. It's over there? It is a leaf blower. Oh, that's evil. Rakes are so much more efficient. Okay. Anyway, yeah, it's the scourge of my existence. I go out on my deck, and this is what I hear this time of year. It's terrible. Okay, well, anyway, let's go on. Let's get this done with, and then we can just leave, I guess. Okay, who is this? Oh, Sydney and Evan. Sydney, what about CABCC? B, you said? Excellent. Okay, Evan, I guess that's all right. Evan, what about CACBC? All right, back to Sydney, CACCB. Okay, Evan, last one. Okay, good. Okay, I guess there's 3 of you now. Zane, what about CCABC? Okay, very good. Roston, CCACB. Hey, very good. Chelsea, CCBAC. A again. All right. Anyone? CCBCA. Okay, yeah, everyone's like, yeah, it's going to be A because A has veto power. And then I did mine down there. And so now, yeah, so it wasn't as bad as it looked. So let's go ahead and figure out how much power each person has. So, and we'll divide by 20. But remember, when we get to the C's, those C's, we combined them. And you might worry that mathematically this is incorrect. But if you think about it, if we were to write out every one of the 120 permutations, you would have 6 of them that looks like this. And so in 1/3 of those 6, it'll be like, if you call them C, D, E, you'll have C here and then D, or maybe this one's the more important one. So in exactly 1/3 of the however many out of 120, you'll have each of those C's would be the pivotal voter. Okay, so let's get the power index A. A, let's count this up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That doesn't feel right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right, I'm going with it. 13. 13 out of 20. He's playing Pokemon Go now. He's just looking at his phone. Okay, go. Thank you. All right. Anyway, so there's A. Yeah, that feels wrong. I think why it feels wrong to me is because typically you don't end up with weird numbers like that. 13 up there bothers me. But if we multiplied that by 6 to get out of 120, then it wouldn't be just a prime number like that. Okay, and then letter B, how many times do we have? 1, 2, 3. Is that right? Just 3? So 3 out of 20. And then C is going to be the balance. Is that 4? 1, 2, 3, 4. Whoops, it got big. I think there's 4. So 4 out of 20 times 1/3. So I suppose you could reduce that, 4 out of 20, so it's 1 out of 15 is the final thing for each of the C's. So each one of the C's is going to have 1/15 of the power. There's 3 of them. So that's it for that one. Shapely Shubik. Okay, let's see. Are we done? I don't think we're quite done, but we're closing in. Okay, we've dealt with UN Security Council. Oh, by the way, I never showed you this. There it is. So, but you know this. But if you needed the words, you can always look at the video, because I hope I'm still capturing this. Yeah, things should still be going. So you could do that. Here's the list of steps. Okay, so homework. I need to update the homework. I will show it to you. It's pretty straightforward. Let me grab it here. Course. Where's the capstone? Oh, I was looking at it right here, and then I just reset. Okay, homework. There it is. So pull this over. And I'll look and enjoy. Okay, so it's not there yet, but I'm about to put it on there. Here, let me just do this here. So after you leave, I'll do this, but I'll speak it, and then you can see what it is. Basically, what you're going to do is you're going to do the same thing for this one, and this one. So you've got these same 4 ones. So I'll just copy this. But in this case, you're going to do the Shapley-Shubik power index for each one of these, and then when you get down here, do the Shapley-Shubik index for the UN Security Council, which is horrifying if you think about it. 15 voters, 15 factorial, way too big. You're not going to list them all off, but remember, you have 5 voters that are all the same, and then another 10 voters who are all the same. And so if you take that 15 factorial and divide it, is it still going to be ugly? Let's see, just a minute. I had thought this would be okay, but maybe not. No, I think it's okay. 15 factorial divided by 5 factorial times 10 factorial. It's still 3003. That's too big. I could have sworn that I've done because we can do bands half, and that made sense. The bands half power index, it was easy. So why can't you do I'm sure there's a way around it. I'll do it. You can do it for fun if you want, but I'll do it. So I'll change. I'll put that down. But for sure, those 3. do them Shapely Shubeck. I'm going to copy it after you leave so that it'll be up there. And then UN Security Council is just for fun if you want to do it, and I'll do it. I'm pretty sure it's possible to do UN Security Council. Sure, you can make a pile there, and I'll just stick it with all the rest that I have to return to you at some point in the near future. Yeah, if you have any questions about career paper or Excel spreadsheet or anything like that, stick around. Otherwise, hope you have a great day. And I'll stop the recording so that no one